Hi guys. Hi guys. Give me a minute guys before I get started. Give me a minute. Hi guys. Rishit, what are you doing in school, Rishit?
What?
What are you doing in school? Rishit,
We're
I wanted
grasping
to
national
talk.
attention.
Yeah, I wanted to actually talk to you last week itself. How are you doing in school? What are you doing in school?
We're graphing rational equations.
Graphing rational equations. Okay. How, meaning, um, how is overall algebra 2? Are you going to CB geometry?
Yeah,
Are you going to take it as a part of school course?
yeah. No, I'm gonna UT Austin, UTHS it.
Are you going to take the course or the exam?
Course.
That that takes 1 year, right?
Yeah, but I'm doing it online.
Oh, in parallel with this?
Yeah,
Okay, that makes sense. Okay, in parallel with algebra. Oh, in parallel with algebra 2 or pre-calc?
algebra 2, because we have to finish geometry as well as algebra 2 to do pre-calc.
Okay, when did you start? Have you started already?
Um, I'm buying it in a few days, the course.
Oh, okay, you're buying it in a few days and you'll complete before what they have asked you to complete.
Um, July 15th.
Yeah, you have time. Okay. Okay. Let me know if you need any help. Make sense?
Okay, okay.
Okay. How are you doing in algebra 2?
I'm doing good.
Okay. Okay. So we did till 489 inverse variations, right? So let's see. Any questions on the homework, guys? Any questions on the homework?
Not really.
Okay, I'm going to get on to rational function graphing. Last week itself I started, right? So let's go ahead with rational function graphing was my thought. Can I keep moving with rational function graphing? Avni, any questions? Ishita, any questions? Shrikar, did you have a question on the homework? I wanted to check a couple of things. Did any of you have any questions on the homework?
Nope.
Okay. Akshada, did you have ma? Hey, are you all checking your homework, guys?
I didn't have any.
Okay. Krishiv, how are you doing? Are you able to understand what we are doing?
Me, yeah.
Yeah, but I didn't see your homework. Were you able to go through those?
I went through a little bit of it, but not the entire thing.
Okay, that's good to know. Rishit, did you have any questions?
I did my homework. I couldn't submit it. I had no questions overall.
Okay, so let's move on. Whose mom is Danya Meda?
That's my mom.
Okay, I just wanted to be sure. Okay, I don't see Annamadvait at all. Oh my gosh. Okay, anyway. So let me make it.
Anna won't be here. She has a soccer game for her school.
Oh, is it ma? Okay.
Yeah.
And how is she? Is she doing her home? I want to talk to your dad. Just tell your dad that I want to talk to him sometime. Make sense?
Yeah. I was working through the past homework and then I finished that first one you told me to do.
Okay, were you able to understand something out of it?
Yeah.
Okay, which one did you do?
I just went back and picked one.
Oh, you just went back and picked. Okay. Yeah, I think that's required out of you. Okay, keep doing that as well. Okay. Now, we solved rational inequalities last week. Huh? Okay, rational equations last week. So I'll continue with that, a review, and then I'll move on to. Hey, Avni, you did your test very well. Did you see that, Avni?
Yeah.
Happy? Good to know. That was surprising to me too. A pleasant surprise, I meant. Okay. Yeah, a few of you have done very well, excellently. Okay, I was good. I was pretty happy to see. Okay, now let's go ahead and see this one. F of x equal to x plus 3, x minus 1. What do you think? Meaning, okay, let's go ahead and find out the domain of this function. How to find the domain of this function? How to find out? We are going to graph it, guys. First of all, let's understand how to find domains of functions. Go ahead. How will you find the domain of this function? Let me know if you have any thoughts.
You put it in a table, and then whatever points make the asymptote on the denominator
Correct. Great.
won't
Okay.
work.
So we'll start with finding the asymptote. I really like that. Okay. So for that, we need to talk about the excluded values. What is the excluded values here?
1 and -3.
Excluded value? Why negative 3? Ma? Negative
The
3?
top.
Yeah, top we don't see. What can
Okay,
make this entire function undefined
1.
is the denominator becoming 0. Denominator can never become a 0. Denominator can never be equal to a 0.
So
So
just 1.
always, yeah, x minus 1 equal to 0 if you equate it, x equal to 1, right? So that is your excluded value. If the excluded value is that, then coming to the domain, how am I going to define the domain? X is not equal to 1, but is an element of real number, right? What does that mean? Let's write out in all the notations. Inequality notation, minus infinity to 1 and then 1 to infinity. 1 is not included, that's an asymptote. I'm sorry, this is interval notation, right? Coming to writing it in inequality notation, minus infinity less than uh, inequality notation, how are we going to write? Can I write it like this? Ishita, are you following, ma?
Yeah.
Huh?
Yeah, I am.
X less than 1 or x greater than 1. And what is the next notation? Set notation x. X is an element of real but x not equal to and x not equal to. Make sense, guys? Or you can just write this in here. Make sense? Okay, so you will look at the denominator to see what is the asymptotes. Sometimes you might have multiple vertical asymptotes as well. How about this? I really want you to tell me 2x square minus 3x plus 9 divided by, let's see how we do this, x square minus x minus 6. I don't want anything from you. We are not there. We will not graph it right now, these functions. Okay. But we are going to learn that. I really want you to just identify the domain in let's say interval notation. That's easy to type, right? Just the interval notation of the domain I want for this function. Can you try? And after that, let me try. Go ahead, guys. Let's go ahead and try that. We will do nice graphing today. Slant asymptote maybe we'll do next week. Let's see. If we learn graphing, a bulk is done. Let's see. Would we be able to write the domain of this rational?
Yeah.
Akshada, you are going to write your exam for sure, right? CB? Not
Yeah.
sure. Amma? Just send me a message. That's the plan, right?
Yeah.
It is still the plan, right?
Yeah, I'm still doing it.
Yeah, that only puts you into a better situation, irrespective of whatever you're going to do next year. You got it?
Mm-hmm.
Meaning, yeah. Meaning, complete it here. Whatsoever you complete it here. You got it? Yeah. So, whatever it is, you'll be in a better situation.
Yeah,
Go.
I'll do it here.
Abhay. Not really, Abhay. Is your denominator a repeated root, you think?
No. Hold up. I think I did something wrong.
What is it?
I think I did something wrong.
Okay, Rishit, did you get what is the domain in this?
Yeah, I typed it.
You typed it. Oh my goodness, how did I not see it?
Priyanti, could you send a message in the
Yeah,
chat?
absolutely. Oh wow, Rishit, good job. Have you started learning this at school, Rishit?
Yeah, we learned it today.
Oh, today, okay. Okay, what we did, rational equations as well, you have learned it, Rishit? Did you start, did you start graphing rational functions?
Yeah.
Okay. So x square minus 6 minus x minus 6 is there, right? So here what you can do is you can factorize it. How will you factorize it? X square minus 3x plus 2x minus 6, right? So just the denominator will do. We don't want the numerator now, okay? Now that becomes x times x minus 3 plus 2 times x minus 3. When you factorize it, that becomes x plus 2 x minus 3. So your denominator, the entire term, can be like this. Put it in intercept form. Then what can make x equal to 0? If x is equal to minus 2, it's a problem. X equal to 3, it's a problem. Correct? So domain has to exclude those points. So when you graph it literally, guys, when you graph it, x equal to minus 2 will be a vertical asymptote. Okay, x equal to 3 will also be another vertical asymptote. The denominator factors are all vertical asymptotes. Any questions? Those are the places where the graph will become undefined. Make sense? Okay, so now you got it. Let's see. How about this? Let's see this one. I want you to tell me the end behavior. Okay, now we discussed the domain, how to find out the domain given a rational function. Ishita, did you get? I'm not getting answers from you. What does it mean, ma? Shrikar as well. Krishiv, are you doing?
I was writing my answer, but then you put it on the board, so I didn't.
No problem. So you got the same thing?
Yeah.
Okay, how about this? Okay, this was an expression that I gave you before. Okay. Now, for what did I give you this? I asked you to define the domain, remember? So we did that. This is done. Now, I want you to tell me about the end behavior. You all know what is an end behavior, right? When this is the end behavior, as x goes to minus infinity, what happens to my f of x function? As x goes to plus infinity, what happens to my f of x function? That's what is the end behavior. You don't know how to do this, right? You know, to start with, the way I want you to learn is, this is what is better, guys, okay? X, f of x, you can use a calculator, okay? So do it like a 999 minus, change it to, as x tends to minus infinity is what I want to calculate first, right? So I'll go ahead and calculate minus 99, then minus, okay, so this is for your minus infinity. For your plus infinity, what you'll do, just change it to plus 99 and 999. Can we try this, guys? So basically, if it is, let's substitute a minus 999. Minus 999 plus 3 is minus 996 divided by minus 1000. So what happens here? What happens here, guys? It's positive, right? Are you all seeing that as a positive number?
Yeah.
Oh, but you know what? Okay. Yeah. So this will be a positive number. Good. Okay. If it is a minus 99, what happens? Minus 96 by minus 100. I'm still seeing it a positive number. Do you see it? 0.996, 0.96, and then plus 99, what happens? 99 means 100. Okay. Now, at minus infinity, what happens? This is minus infinity, right? So it seems a positive number, 0.9999. Okay, so it's almost, see? So where is it nearing? When it is a minus 9999, where is it nearing? What it is trying to touch? The y value. Y value is trying to touch what?
0.
You think it's a 0? Okay, okay. What do you think it's trying to touch? If it is towards your most negative, right? Is it trying to go, okay, if it is a minus 99999, then it becomes what? Minus plus 0.999999996. So, okay, no problem, guys. Let that be aside. Now, what was the asymptote? X equal to 1 was an asymptote, right? So here, if x equal to 1, then it becomes undefined. So I draw this asymptote. Now, let's describe this function towards the asymptote. When the function comes towards the asymptote, meaning left and right of asymptote, what happens? Can we try? Meaning 1 is here. What is this? 0.99 is here, right? This one is 1.1, correct? Now, let's try both values. Okay, let's leave the minus infinity plus infinity. When I go here, 0.99, what? See, this is not how we are going to do it, but I want you to know this is how it happens. 0.99 plus 3 divided by minus 0.01. What happens here? What will be the value, guys? You tell me. 0.99 I substituted. So it's going to be a negative value. What happens? This one is what? Multiply by 100, multiply by 100. So it is going to become 99.13. Can I say minus 99.13?
Yeah.
Can I say? Guys, are you all with me? Can I say?
Yeah.
It is point. Can I say that? Now, what will happen here? This is 0.99. I did 0.99 minus 1 is what? 1.00.99. No, this was wrong. Guys, are you all substituting 0.99 into the equation? Tell me the value of this, I said. Can you do that? This is not correct. This value is not correct. I really want the y value when you substitute x equal to 0.99. And I also want the y value when x equal to 1.1. Can you do that for me? I'm going to wait, guys. You're going to substitute 0.99. You're going to substitute 1.1 and let me know. What were the values? .99 means what's happening, guys?
Is
Negative.
the for 0.99, is it negative 39.9?
Negative?
39.9.
Negative 39.9, huh? Yeah. Okay. This one, 1.1?
I'm doing it.
I got 41.
Plus 41, Amma?
Yes.
Yep. Okay. So what does it mean? Okay, let's try this 0.999. It's even closure. What happens 0.999? It's even closure here, 0.999. What will happen to this value? Is it extremely negative? If you substitute,
It just gets closer to the.
it just closer to what, ma? Okay. What I'm saying is 0.999 plus 3 divided by 0.999 minus 1. Let's see. This becomes 3.999 divided by, this is 1.000, 0.999. I'm going to subtract and add a negative. So 1, this one. This is what I wanted you to do. Right? So this is going to be minus 0.001. So what is the answer for this? Basically, 3. Okay, this is 39 minus 3999.99. Correct, guys? It's extreme. See, it's going extremely negative. So can I say how do I describe the graph? What can happen to the graph if I move my x value from 0.99 to 0.9999? See what an increase this is. Negative 39 becomes negative 3099. So do you think my graph goes like this? It becomes extremely negative. Do you see? As it approaches 1, it becomes extremely negative. And as it approach after that 1, right, it is becoming extremely positive. So my graph is going to go something like this and like this. Do you see? As it approaches, this is x equal to 1. As it approaches 1, it's extremely negative. It goes to negative infinity. As it after that, right, after approaching negative infinity, right, at 1 the function is not defined, and when I put in 1.1, suppose you put 1.999, it will be extremely positive. If I put 1.1, it goes to a 41. So from positive infinity it's coming down. So basically things like this you should know in a rational function, meaning given a rational function, towards the asymptote what happens? Towards minus infinity and plus infinity, what happens you need to know. Does that sound good, guys? Okay, we don't need to do this plus infinity minus infinity as yet. I'll do one more problem, then you'll clearly understand. How about this? Can I say here itself, before I move on, right? Can I say instead of this minus infinity, negative infinity, we will anyway do. In behavior, we have to do, don't worry about it. Can I say it like this? As x tends to, what is this? As x tends to what? Maybe 1 minus, meaning a little below 1. 1 was the asymptote, right? So a little below 1. What happened to f of x? F of x tended to what? F of x was wanting to go to what? Below 1. As x tended to 1 minus means this is the 1 point. 1 minus means left of 1. What happened? F of x tended to? Subi, you tell me. Subi, go ahead and say, what do you think?
Like below 1?
Illama. this is a number line. This is 1. Okay. When I lower my x value, 0.9, 0.999, what happened to my y value? It was becoming
It becomes a higher negative number.
higher negative. So can I say f of x tended to minus infinity?
Yeah.
Okay. Similarly, 1.1, as x became 1 plus, what happened? It became extremely 1 plus.
Positive.
After 1, what happened? It was extremely positive, right?
Yeah.
Okay, good. Let's see. So that's how you do. This is not okay. Here I'm not defining my end behavior, but at least towards the asymptote I'm trying to define. I have not dealt with minus infinity and plus infinity yet. It will be part of graphing. Let's do one more problem. Let's see where we are. How about this? X plus 5, x minus 1 divide by x plus 1. Can we try this one? Okay. What I'm going to do is, what is the asymptote here? You tell me. What is the excluded value here? What is the vertical asymptote here?
-1.
-1.
Yeah. Now let's draw. -1 is here, right? So I'm going to draw the vertical asymptote. I'm just going to describe the behavior of the graph around that vertical asymptote. Okay. Let's see. For that, what I need to do, I have to draw a table. I have to describe the left and right. -1 is undefined. When I say -1, f of x becomes undefined. Okay. Now, before -1, what can be the value? What will be the value before -1? This is -2, this is -1. This is -1 point. Can I say -1.11111? Can I say this is -1 point? Or I can say -1.111, I can say, right? Guys, are you all with me?
Yeah.
Okay.
Yeah.
Okay, and then I can say minus 1.5 as well, right? Minus 1.1111, or I can say 1.5 is a little after, minus 2 is little after, right? Do you see? This is minus 1.5, this is minus 1. So to the right, what happens? What and all I can say? Can I say minus 0.9999, then minus 0.9, then can I say 0.1? Can I say like this? Now guys, I really want you to quickly substitute. If I substitute minus 2, what happens here? Let's substitute minus 2. X equal to minus 2. If I substitute x equal to minus 2, this is 3 times minus 3 divided by minus 1, correct? So this is minus 9 by minus 1, which is becoming 9. Okay, so I'm going to put it in a different color for you to see. This is 9. Minus 1.5, if I put it, right? Substitute x equal to minus 1.5. What happens? Help me guys. 3.5 minus 2.5 minus 0.5. Correct guys? So that will become 3.5 times 25 by 5. Right? 3.5, 5 5s are 25, 2 5 3s are 15, 16, 17 I'm getting. Is it minus or plus guys? Minus or plus? Yeah. Plus. 5 5 3s are 15, 5 3s are 15. 5 is a 25, 2 5 3s are 56, 17, 17.5 I'm getting. Okay. Now, one of you substitute minus 1.11111 into the calculator and tell me what happens here. So, let me substitute x equal to minus 1.11111. If I substitute 1.11111 plus 5, then 1.11111 minus 1 divide by 1.11111 plus 1. If I do that, this is 6.11111, then times 0.11111 divide by 2.1. What is the answer guys? What guys, you have to let me know quickly. Use a calculator and tell me. Are you getting a positive? Yeah. What's the answer you're getting?
I'm getting like 0.3216 and then it keeps on going.
0.32
and then it just keeps on going.
Is it like this? It's not making sense to me. because x plus 5, right? Oh my god, you know what mistake I made? What mistake I made? You never told me, guys. This is minus, I'm saying, right? See, minus, minus, minus. So this will be basically this is 4 not 3.999. 3.9999. This one would be minus 2.11111 divided by, this is, what should I divide it by? 1 point. So this would be 0.11111. I feel like it's going to be a big positive value. Can you check? It's going to be a big positive
Negative
value.
number.
Huh?
I got a negative number.
Wait, Ma, are we doing it correctly? No, right? Okay, it will be a positive value because denominator is also negative. So what's the answer? Everything will be positive value because see, numerator and denominator negative. So what is the answer?
76.
76, huh? See.
Mhm.
So in this piece, it's a big positive number you're getting. As and when you near 1, it is a positive piece, meaning what happens? The positivity goes on increasing. What happens on the other end? Other end is, if you substitute, can you substitute here minus 0.999 and tell me, ma? If you substitute 0.99999, what happens? Yeah, I think we're doing it right. Did you get it? Minus 0.9999?
Where am I substituting it again?
In the function, ma.
Oh, okay.
Directly in the function. That's what is f of x, right? So let's substitute and see. Substitute x equal to minus 0.99999. You substitute that. Literally, you'll have to substitute instead of x plus 5.999. That is also minus 1 divided by minus 0.9999 plus 1. What is the answer, ma? One of you tell me the answer, guys.
Giving me something weird.
Yeah, it's okay. What is the answer?
Like -4 something 1.
Negative?
Wait, let me double check if I put it.
High negative you'll get.
Yeah, it's a very high negative.
Very high negative. Okay. Do you see? So what happens to the graph? Very high negative. So it went up when it approached 1 from the negative, and when it approached 1 it went up. What happened after 1? It became very high negative, and it goes like this. Make sense, guys? So how to write the end behavior as x up? I'm sorry, this is not the end behavior. It is behavior around the asymptote. As x tends to what? Minus 1. See, minus 1 to the left side of minus 1 is more negative, right? So minus 1 minus. This minus 1 is your value, minus 1. Left of minus 1 is indicated by a negative value. Right of minus 1 is indicated by a positive value. X goes to the left of minus 1. Right? What happens? Y goes to f of x goes to infinity. Suppose if we are moving to the right of the asymptote, what happens? Your graph goes to, anybody? Your graph goes to, guys, tell me, guys. Huh?
Negative infinity?
Yeah, negative infinity. Do you all get it? Is a little difficult to understand though. Let's see. How about this? How about this? X minus 4 divided by x plus 1, x minus 1. Okay. Can you tell me the behavior of the graph? Behavior of f of x around x equal to minus 1. The graph actually is like this. When you think about it, this is an asymptote, this is an asymptote. Let me not draw it like that. This is your y, okay? This is x equal to 1, this is x equal to minus 1. When you think about it, right? So how will the graph behave? Meaning, let's say 1, Okay, this is 0.99999. This is 0.9. You see, just substitute that value and see approximately you will understand what happens. And then for this one, you try 1.11111 and then try 1.1. Both you will get the nature of the end behavior around the asymptote. You're just going to plug in these x values into this equation. First you're going to plug in 0.9. Next you're going to plug in 0.9999. We are approaching 1. And then after that what happens? 1.111 to the right side. Then you're going to write out 1.1. Can we try this one, guys? Or let's make it a little bigger, 1.2 maybe. We'll do this. Can we try? Quickly, please give me 4 values. I will just draw and we can describe the end behavior as x goes to, this is your value, x value. Okay. We are only discussing to the left of means a negative. This indicates why 1 is your x value. We are talking about where the graph is to the left of that point. Here we are talking what happens to the right of 1. Can you tell me what happens to f of x? Rishit, did you get it?
Yeah.
You're going to tell both the
Yeah.
end behaviors. Yes, pa. Go ahead. Done. Done, guys?
Almost. Go ahead, guys. Did you get it? How many of you didn't get it? Please tell me if you didn't get it. Akshara, you got it? What we are doing? Avni, did you get it? Oh, good. Okay. Krishiv, did you understand what we are doing? We are trying to predict what will be the value of our graph when our x value is to the left of 1 and to the right of 1. That's all.
Yeah, I understood.
Okay, great. What did you get? This goes to what? Understanding this nuance is very important to graph rational functions. Got it? Somebody tell me, guys. Nishita, this time you tell me, ma.
I'm not sure. I'm still working on it.
Okay, you're not sure now. Are you able to proceed or not, ma?
Like, I understand it, but I just don't know, like, I don't understand the whole thing.
Okay, how can I help you better, ma?
How do you get the different points?
What are your points? What will make this function undefined?
Negative 1 and 1.
Positive, -1 and +1, correct?
Yeah.
I'm going to describe the graph before this point, after this point, before this point, after this point. Okay? The first point I took for consideration is, okay, x equal to 1 first. Okay, so behavior of f of x around -1 and x equal to 1. Both the things we need to find out. Okay, -1 is a little confusing because both are negatives, right? So I took up for x equal to +1. First, I am going to investigate for x equal to +1. What is the number before this, Ishita? Two numbers before this in decimals. 0.9999 is before 1. 0.9 is a little before, right? That's why I took these 2 points. You got it? What is the number after 1? 1.111, 1.2, right? That's why I took those 2 points. Got it?
Yeah, that makes sense.
I plug that into my f of x function to find out the 4 values. Anybody can say? Or otherwise just say, when you go to the left of this 1, the graph goes to where? It has to go to plus or minus infinity only, but you need to find out what where. Yes, Avni, tell me.
As x goes to the left of 1, I got that f of x goes to negative infinity.
Oh, like this, Amma?
Yeah.
Oh, good. Okay, negative infinity. And then?
As x goes to the right of 1, I put that y goes to infinity.
Is this right, guys? Let me check once, guys. X equal to 1, right? X equal to 1. X approaches 1. X approaches 1. 1 plus means correct. 1 plus means. Guys, did you all get that? All of you? What did you get, Akshada?
I got the opposite.
That's what the opposite is, right? Avni, do you want to check once? I really want you guys.
I think I made a small typo when I was putting it in my calculator.
If you by mistake forget a minus, gone. Go ahead. Did you get the opposite as well, Avni?
Yeah, I put it in again and then I got it
Okay,
right.
Akshada, you got the opposite of this, right?
Yeah.
Avni, did you also get the same thing?
Yeah.
Subi, what did you get?
I got as x tends to the left of 1, y
This is the left
tends
of 1.
y tends to positive infinity,
Correct, that's right.
and then the
Positive.
opposite
That's right.
for yes.
Yep, you all got it. So how does the graph go? Left of 1 is going to positive infinity. Somewhere the graph goes like this. And then when you want to continue the graph after 1, right? From minus infinity, I'm coming up. You got it? Why we are so much emphasizing on this, when we go to graphing of rational function, there will be so many asymptotes. We need so many. Horizontal asymptote will be like this, vertical asymptote will be like this. So everywhere you need to identify before and after how the graph goes. That is why we are slowly going line by line. So this is the only Abhay, what happened? Advait, are you getting it?
Oh yeah.
Yeah, I'm following.
Okay. So to the left and right of the asymptote, we need to understand the nature of the graph. Okay. 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 So let's go ahead. Okay. Now guys, okay. I want you to tell me more. Let's see. How about the range, guys? Okay, let's see. I'm not bothered about the range now. Horizon, first of all, you need to find out the horizontal asymptote. I don't know. Let's see. Okay, let's go ahead. Now, how about this? For rational function graphing, I'm going to give you a cheat sheet. Meaning, cheat sheet in the sense, what are the steps we are going to follow? And every time you're going to follow the same step and you're going to build a habit. Okay, let me see whether I can take that cheat sheet first. Okay, let me show you. Let me bring up, show you. Let's see. This is little complicated, guys, but if you follow the instructions, if you follow the steps one by one, right, you'll never make mistakes. Steps is not for memorizing. Just that rational function graphing, right? Yeah, just that what you need to find first, second, like that. Okay. Now, I'm going to share screen with you. I'll share this in the Google Classroom. How about this? Here we go. Are you all able to see my screen? Guys, you have to tell me yes, no and stuff. Okay, for any rational function given, right, what are we going to do? First of all, we are going to determine the horizontal asymptotes. Okay, after that, factor the numerator and denominator. For me, factoring comes first. Whatever quadratic function or cubic function given, if you are given whatever, numerator and denominator should be factored, and then horizontal asymptote should be found, and then we are going to find out wholes, vertical asymptotes, and then we will find out zeros, roots and x-intercepts. So this will, see, this is the same thing. Basically the left column is the same as right column. What we are going to learn today is all these 5 steps we learn. You'll never make mistakes if you follow the same 5 steps. Any questions here? Okay, so to graph a rational function, let's go ahead. First, we are going to find the horizontal asymptotes given a function. Okay, let's go to step 1. I'm going to bring this in there. Okay, you're able to see my screen now, guys. Do you see my screen? Okay, now let's say I'm going to give you a rational function. I gave you, right? Remember, f of x equal to x plus 3 divided by x minus 1. Now, there are 3 cases. As soon as you're given a rational function, I want you to tell me what are the horizontal asymptotes. There are 3 cases. Okay, let's say, what is the degree of the numerator, guys? What is the degree of the numerator? What is the degree of the numerator? Polynomial, right? What is the degree of the numerator? Guys, go ahead and shout out. Highest power of x, right?
1.
1. What is the degree of the denominator?
1.
1. Both are equal. Unfortunately, both are equal. Okay. If both are equal, what happens, you know? See here. If both the degree of the numerator and the denominator, they call it m and n. The degrees are called m and n. If both are equal to 1, right? M is equal to n, right? The horizontal asymptote is the coefficient of the highest term divided by the coefficient of the highest term in the denominator, 1 by 1, which is 1. So y equal to 1 is my horizontal asymptote here. Make sense? Suppose if you are given a rational function like this, what happened here? What is the horizontal asymptote? This, here, the degree of the numerator. What is the degree of the numerator? What is the degree of the numerator? Come on, guys.
1.
No.
0.
X power 0, right? That's 1, right? So 0, degree of the denominator?
1.
1. So numerator is less than denominator. So the horizontal asymptote, you can blindly say y equal to 0. X-axis is your horizontal asymptote. Make sense? The last one, sometimes you'll get it like this, guys. This is really horrible, I tell you. Divide by x minus 1. Wait. Yeah. This is a very weird situation where my numerator power is huge. Do you see? Degree of the numerator is greater than your degree of the denominator. Then you do not have any horizontal asymptote. You have only slant asymptotes. That's even weird. Okay. So you don't need to consider this. This is all complicated. We'll go to next week. Okay. So now the degree of the numerator is less, means y equal to, by default, this is your most case. Okay. Mostly you will get only this. Okay, it's like this, 1 by x minus 1, or it can even be x minus 1 by x square minus 2x minus 1. If it is like this, right, you see the degree of this is 1, the degree of this is 2. So as a result, numerator is less. That means y equal to 0 is your horizontal asymptote. That's the most common thing you'll get. But sometimes they both will be equal. When that is happening, then you have to find the coefficients of the highest powers of x. Okay, you have to divide them. Make sense, guys? This is a complicated one. So let's see. I'm going to give you questions now. I'll let this be, okay? But slowly you'll have to memorize this. I can't have this on the board, okay? How about this? X plus 1 by x minus 2. If this is my rational function, what is the horizontal asymptote here? You know the vertical. Where is the vertical asymptote? Where is the vertical asymptote? That we already learnt. Where is the vertical asymptote? What vertical asymptote means? What will make the function become undefined? Your excluded values. So what is the vertical asymptote, Abhay?
2.
X equal to 2. Correct. What is the horizontal asymptote? Tell me. Rishit, you can as well tell me. Rishit or Abhay, tell me. What is the horizontal asymptote?
-1. Is it 1 over -2?
1 over?
-2. Or -1.
Why 1 over? See, the degrees are both equal, right? 1, 1, right?
Mm-hmm.
Guys, are you all listening? Rishit, I don't think you're listening, Rishit. You were not at all listening for the entire explanation, I feel. So without listening, you won't get any of these. Huh?
I just forgot.
It's here, right? If you were, then you should be able to say, right? Horizontal asymptote. The degree of the numerator and denominator are? How are m and n?
They're equal.
They're equal. So what happens to the horizontal asymptote?
It'll be the non-variable number over a over b.
So the leading coefficient 1 by 1. So y equal to 1. You got it?
Yeah.
Y equal to a by b. A is the coefficient of the leading term in the numerator. B is the coefficient of the leading term in the denominator. There is no other go, but slowly you will have to push this into your brains. How about this? Suppose x square plus x minus 2 by x square plus x minus 2 divided by x plus 3. What is the horizontal asymptote for this? What is the degree of the numerator? What is the degree of the denominator? Based on that, there are 3 cases. Sometimes degree of the numerator can be bigger. Sometimes degree of the denominator can be bigger. Sometimes they both can be equal. So here, what do you think is the case? They're called mn. So here, which is greater, guys?
The numerator.
Numerator is greater. If the degree of the numerator is greater, see here, there is No horizontal asymptote. Make sense? Okay. Then the next one, let's see. X plus 1 by x square plus 3x minus 4. I'm changing it. Okay, I'm changing that problem. X plus 1 divided by 2x square plus 3x minus 4. What do you think about the horizontal asymptote for this?
Y equals
What
0.
Huh?
It's y equals 0.
Good job. Y equal to 0. Why? Degree of the numerator is less than the degree of the denominator. Correct? Now if I put it like this, it's another question. What is the horizontal asymptote? I put x square plus 1 divided by 2x square plus 3x minus 4. What will be the horizontal asymptote? Huh?
Is it 1?
Why 1?
Is it 1 over 2?
1 over 2. M is equal to, and degree of the numerator is the same as the degree of the denominator. So you take the leading coefficient. What is the leading coefficient? Nothing is in here, it is 1. So 1 divided by 2. So y equal to half is your horizontal asymptote. What is it horizontal asymptote? Means at y equal to half. This is half. This is 1. So the horizontal, there will be a horizontal asymptote like this. Graph might be like this. You got it? Meaning at that point, y value, the graph value is not defined at that point y equal to half. Makes sense? The graph becomes undefined. The range, right? Range of the graph does not, meaning that's an asymptote. So range does not go to the horizontal asymptote. But you know what? After one class, I'll tell you that the graph crosses horizontal asymptote. That's even more complicated, right? Yes. In rational functions, coming to the horizontal asymptote, right? Graph, there are graphs that cross the horizontal asymptotes. That is a very, very special case. For now, let's consider that it's a horizontal asymptote and graphs are not going to cross horizontal or vertical asymptotes. Okay, for this class, we will consider that they are asymptotes and our graphs are not going to cross horizontal or vertical. But I will change it soon. Can I go ahead now? So you know how to find out the horizontal and vertical asymptotes. Make sense, guys? Now, I'm going to go ahead and show you how to find the holes or discontinuities. Meaning, sometimes let's say I'll show you an example graph. Okay, this is a rational function, right, guys? This is a rational function. This is having only, see, it has a vertical asymptote, it has a horizontal asymptote. There's nothing about it. Okay, sometimes they may draw the same graph with a hole here. Okay, meaning the graph comes here, but after that the blue line is not there. It's undefined at that point, let's say minus 3. If they give you a graph like this, this is called a discontinuity in the graph. Why? Because the graph is not defined at x equal to minus 3. So it's called a discontinuity. But from your equation, you should be able to find out where is this discontinuity. If you want to find out these discontinuities, if you're given a function a of x by b of x, you're going to factor this completely, okay. After factoring, let's say you factor this out. A of x is x minus 1, x plus 3. B of x is x minus 1, x, let it be. Now, in this scenario, when you think about it, this gets cancelled, right? When you factor out, one of the factors is getting cancelled, right? Whatever factor you end up cancelling, what is that? X equal to 1 is your discontinuity, is the hole in the graph. Makes sense? When you factorize the numerator and denominator polynomial into linear factors, if there is a factor that's going to get cancelled, that becomes your hole. We are learning a lot. First, we found out how to find out the vertical asymptote. Vertical asymptotes was very easy. You knew excluded values and you related that to vertical asymptotes. Then suddenly we said, oh, this graph will have horizontal asymptotes as well. There are 3 cases. Please look at the 3 cases, and one of the cases will give you the horizontal asymptote. And then now we are going ahead and saying, hey, there will be some discontinuities in the graph. Those are called holes. How to find out the holes? You are going to factor the numerator polynomial and the denominator polynomial. Once you factor out, if there might not be any holes as well. If only there are cancelable factors, then the graph is said to contain holes, and those are the factors that are getting cancelled. Shrikar, are you following?
Yeah, it's kind of hard, but I'm getting it.
Following. Okay. Only 3 things we did. Okay. We'll do those 3 things in a graph. Okay. I'm not going to go. Okay. After all these, we can talk about zero, domain, range, and symmetry. We'll do that later. Okay. First, let's go ahead and try one graph with all these. Vertical asymptote, horizontal asymptote, and what did we discuss? What did we discuss? Vertical asymptote, horizontal asymptote, and holes. Let's try. How about this? No, I don't want you to do a hard one today. Let's see. Okay, how about this? Okay, how about this? That's a good one. How about this? You're going to find out everything for me. F of x equal to x square plus 2x minus 3 divided by x square minus 4x plus 3. You know what I want you to do for this one? You're going to find out the domain. Okay, and then you're going to tell me if there are holes. Does this graph have them? Okay, if yes, find them. If no, fine. Okay, domain we discussed, holes we discussed. I don't want end behavior as yet. Okay, but I would like to know about vertical asymptotes and horizontal asymptotes. Can we find them?
Miss Priya,
Yeah.
for the domain, do we have to find in all 3 notations?
Yes, actually, yes. To be very honest with you, yes, you need to know. But here, for now, for today, I just want interval notation.
Okay.
Okay. But basically, you should know how to write. But for now, I am okay if you don't show. Go ahead. You're able to, ma? Are you able to? Who's not able to? Who's able to? What are you all doing? Factor it out. That's the first step. But before factoring, please identify what? Horizontal asymptotes. Identify horizontal asymptotes before factoring. After factoring, find out what are the factors that are excluded values in the denominator. They become the vertical asymptotes. When you factorize, are you able to cancel any of the linear factors? That gets you the wholes. When you write out your domain, think about this. When you write out your domain, all your vertical asymptotes are excluded. Wholes are excluded. Wholes are discontinuities in the graph. Abhay, is it difficult or is it making sense?
I just put my answer in.
Oh, you put your answer. Nice. So you got it. Nice. Hey, sorry guys, I did not see left. Shrikar, I'm waiting for your answer, correct?
Yeah, I'm putting it in.
Yeah. Akshada. Vertical asymptote at x equal to. No, are there two vertical? Oh, Amma. See. 1 minute. You cancelled it, right? Akshada, after you cancel, right, ma? Vertical asymptote, you whole, you have put the same value in whole as well as vertical asymptote, right, ma?
Yeah.
You put the whole, okay? Whole takes precedence. You don't have to put that because you cancelled it out. It is not a vertical asymptote.
Oh, okay.
Make sense?
Yeah.
Okay. Nice, but everything is right, lady. You can log off. Domain, did you get it? Correct. In the domain, whole is also a whole. It's a discontinuity. At that point, x equal to 1, the graph is not defined. You got it? So, yeah, everything is right.
So once I find the whole, I just take it out of everything else.
You just take it out of the domain only.
Like
yeah.
I don't include it.
Yeah, meaning.
Like I put x is not equal to 1 once, but since I found the whole, is like I found out the
You
whole.
found the whole, right? So that goes into the whole. Let me write it down for you. Can you tell me how did you factorize this? What was the factored form?
X plus 3 and then x minus 1.
And then next one?
X minus 3 and x minus 1.
Good. Okay. Now, here you're cancelling, right? So, clearly, whole is x equal to 1. Now, this is your excluded value. That becomes your vertical asymptote. And then, horizontal asymptote. Aha! The degree of both are equal. So, the leading coefficient of both is 1, 1. So, y equal to 1 by 1, which is nothing but y equal to 1 is my horizontal asymptote. Did you get it?
Yeah.
Domain, when you write it, right? Domain, we'll have to exclude everything. X is not equal to 1, x is not equal to, again, x is not equal to 1, and then what else is excluded? Yeah, this one, x is not equal to 3 as well. So when you write it in interval notation,
I have a question.
Go ahead.
How would that factor to x plus 2 times x minus 1? Wouldn't it be x minus 3 times x plus 1?
Did I give it to you wrongly? X square plus 2x minus 3, x square I just went with one of yours, but that's okay. They might have gotten it wrong. We can check. What did you get, Abhay?
I factored it to x minus 3 times x plus 1 over x minus 3 times x minus 1.
You got it like this?
Mm-hmm.
But this one will give you minus 2x, right, Abhay? This one, see, x square minus 3x plus 1x. You got it?
Yeah.
This one, let's see this one, x square plus 2x minus x. Wait. This also doesn't seem right to me.
Oh, it should be x plus 3 times x minus 1. And so the x minus 1's cancel out. So your whole would be at. Okay, I get it, yeah.
Did you get like this, x plus 3 times x minus 1?
Yeah. That should be it. I got it wrong, but that's what it should be.
That's okay. Plus 3x. See, we are all helping out each other. Plus 3x minus x, right? So that is 2x. Correct. Minus 3. The factored form should have been like this, Akshada. You might have to fix it. This is x plus 3x minus 1.
Oh, I put 3 in mine.
Oh, okay. So, okay. Denominator ma, is it right? Let's check it out. Minus x, minus 3x, minus 4x, and then plus 3. Correct. Denominator seems correct. Okay, guys. Now, let me finish this. So, there's not much of change. Whole is correct. Whole is whole. Whatever we cancelled. Domain is x not equal to 3, and the whole was at x not equal to 1. You have to include it. So when I write the domain, right, in interval notation, minus infinity till, see, think about it, on a number line, minus infinity to infinity. 1 and 3 are excluded. So I'll have to include that. I'll have to write everything, minus infinity to 1, and then 1 to 3, then 3 to infinity. All union. In between is union. Make sense, guys? Wholes should be taken into account for writing domain, because let's see how the graph will look like. X equal to 1, x equal to 1 is not an asymptote. So x equal to 3 is an asymptote, right? Let's go ahead and draw once and see. I'll show you. This is what is going to come next week. X equal to 1. Okay, that's a whole. I don't know how the graph will be, but there is a whole at x equal to 1. I don't know what is the y value. X equal to 3 is an asymptote, right? Now, what else? A horizontal asymptote is y equal to 1. Oh my god, y equal to 1. You get it? So 1 comma 1 is a whole basically. That's what I think, because suppose x equal to 1 is an asymptote, is a whole, substitute that in here. 1 plus 2 minus 3. Yeah, x equal to 1 is an whole. So for you to find out the value, right? I'm getting this. Okay, we'll deal with it. We'll deal with finding the y coordinate of the whole later. For now, the horizontal asymptote is y equal to 1. The vertical asymptote is x equal to 3. This is the horizontal asymptote. This is the vertical asymptote. And then what? Domain, when you think about it, minus infinity to 1. There is a hole here. I don't know how the graph is going to come, but it's going to come here and then have a hole, and then again there is an asymptote. So it's going to have an obstruction here again, and then it's going to continue to infinity. We don't know how the graph looks like. We'll see that next week. Any questions for me? Okay, guys, I will let you go. Rational function graphing is a little difficult. We'll split and understand everything. Okay. See you all next week.
Bye.
Ishita, did you get it? Ishita and Advait?
Bye.
Bye, ma. Ishita
Yeah.
and Advait.
Bye, Miss Priya. Thank you.
Bye.
Bye, bye. So, hi, guys. One second, guys. One second, guys. Give me
Hi guys. Hi guys, can we start? Sorry for the late guys. Any questions on the homework that you have? Let's go through it. This is Friday. Okay, one thing I wanted to show you guys before even I start. For the month of February, right? For every 3 days, I'm going to let me share my screen. I wanted to let you know this in Google Classroom. Are you all seeing my Google Classroom? Are you seeing no? Please answer, guys. All of you in the video.
Yes.
Okay, so if you're particularly attempting CBE, right? This is one set of review. After this, I'm going to give you another set of review as well, which is going to be challenging. Okay, so when you think about it, you will not see, but you will get to see each of the assignments slowly. Okay, when you look at it right now, do you see spiral review? Chapter 1 is given. Okay. It is due 3rd February. So keep doing these reviews. This is right from the start of geometry. Okay, when you go to the review, it will be very easy. Actually, this was given earlier as well. So this is basically what is concurrence, what is basic things will be asked when we started geometry. Okay, section level quiz is there. Then see, there are 3 chap test is there. Please do everything and make sure you know what is going on. Distance formula, angles, so everything is in there. You got it? Now, like that, see, next one will come out on 1st February. It's not to overload you. I split it out, spacing, meaning spaced it between 3 days. So, meaning I had a space of 3 days scheduled between each of these assignments. So, make sure you do it then and there. When you come to your second lesson, right? So basically it's more into what is it going to be on, the logic, biconditionals, remember, and some proofs. It goes to proofs as well. So it starts with the algebraic proofs that we earlier studied, then a flowchart proof. So there'll be questions and see, there are proofs. So please go through these. It is so useful. Okay. Now, what is not in here is the answer key, right? So let's see this one. 3. I made sure everything has answer key, but I'm just noticing second chapter is not having answer key. I'll give it to you. Okay. So do you see here parallel and perpendicular lines was the 3rd chapter, if you remember, and then parallel lines and transversals, right? So that goes till what? Let's see. See, there's an answer key at the back. See, cumulative test, please go through this definitely. Okay, these are just algebraic properties still. See, there's an answer key at the back. You can check every bit of what you do. Make sense, guys? Okay, similarly, it will go to chapter 4, chapter 5, chapter 6, 7, 8. We might not have covered some of this. 9, 10. Probability is not in here. 3D geometry that we are studying right now, right, is in this chapter. Make sense, guys? So for every 3 days in the month of February, it is getting over only in March. You see, 3rd March. At that time, I'll get you access to another set of assignments. Make sense, guys? Please follow through every assignment. Okay, this is in addition to our weekly assignments. Got it, guys? Okay, this is something I wanted to tell. Now, let's stop this. Let's go back to our homework. Okay, how was 3D geometry homework, guys? Did you all do? Okay, did you have questions? Okay. You know what? Similar triangle geometric mean is something I'm a little afraid that I did not cover, but I will go through. Dia, were you able to do the homework?
Yeah, I just need to take the pictures and turn it in. I'll do that after class.
But you did it?
Yeah, I did.
Oh, that's good. That's really nice. Okay. 1 and 2 you did, guys. Good. Okay. On the surface area, did you have any questions, guys? Any of you? Okay. Okay. Cylinder, right? When you unravel it, what is the shape of the cylinder? If you have studied 7th grade with me, you'll know. What is the shape of the cylinder? Suppose you cut the cylinder. Okay, let's say this is your cylinder. Okay, let's see this one. This is your cylinder. This is your cylinder. Okay. Now, where is it? This is your cylinder. Now, if you want to unravel it, right, it becomes what shape?
Rectangle.
Yeah, the rectangle. What is the length of the rectangle? Hey, did I blur the screen? Yeah, I think so. Okay, go ahead. That's better. Yeah. So now, see, this was the rectangle. This was the cylinder, right? This is circular, right? So what is this for the circle? What is this for the circle?
The area.
This outside bit.
Circumference.
Circumference. So if I unravel, that circumference becomes the
length.
circumference becomes the what of the rectangle?
The length of the rectangle.
The length of the rectangle. Make sense, guys? The cylinder's height. The cylinder's see the cylinder's basic height became the width of the rectangle. Did you guys get it? Okay. So now if I give you a cylinder, ask you to find the surface area, top is circle area, bottom is circle area, right? The curved surface area is what? The lateral surface area is just the rectangle. Make sense, guys? Let's see. Don't memorize formulas, guys, okay? How about let's see. I want to give you some hard questions. Let's do the yeah. How about this? You're going to try by yourself. I've given you the concept, so don't memorize formulas, please. Formulas are given everywhere. Please don't memorize formulas, okay? You're not going to memorize any formulas, just going to go as is. Okay, let's see. Go ahead, guys.
Miss Priya,
Yeah.
are we gonna do it in terms of pi, or are we going to like?
Yeah, you can answer in terms of pi if that
Okay.
makes it easier. Remember, I did not give you the rest of the. I didn't want you to give that clue. Let's first see how you do. Without the clue, you do. A drinking glass is shaped like a cylinder. So you want to answer in terms of pi? Let me add that in. I think that's easier. I don't want any computations. Answer in terms of pi. Let me know if you need help. down the answer anytime. Did you get it, guys? Let's see. I'm going to answer in terms of pi, yeah? I don't have an answer in terms of pi. Let me calculate, guys. 21, 21. Dhruv, something is not working. Yeah, Ashita, I think that's right. Harshita, perfectly right, ma. Johan, not really. Okay. Avyukt, not really Avyukt. Can you tell me, Avyukt? You and I can work it out.
Priya, send my corrected answer.
I'll check my Johan.
Mm.
Please don't memorize formulas, guys. That is the main intent for me. Don't memorize formulas. You'll forget, and in the PSAT exam you'll go say, what is the formula? They are not meaning. We don't want cheat sheets or I'm not seeing your answer. I am not getting that. You and Avyukt are getting 25.5 pi. Can we check, please? Diya, what did you get?
I got 25.52.
Ayyo. Please, let's check. Okay. I know what you guys did. I think you did not realize this. Let's say a drinking glass is shaped like a cylinder that has a height of 7 and a diameter of 3. Height of 7 and a diameter of 3. In this case, right, pi r square h. I'm sorry. I don't want you to memorize formula, I said. Okay. So here, what is the surface area of the drinking glass? A drinking glass is open at the top. Did you all realize that? As a result, base area is what? 9. Base area is what? As a diameter of 3 inches. Okay, so this is 1.5, right? So base area is 1.5 square pi, right? 2.25 pi. This is what I think everybody made a mistake taking the top base area as well. Curve area is the sides, right? Lateral, or I can call it as a lateral surface area, is what? The circumference of the circle, 2 pi r, and then it's going to be a rectangle, right? Times h. So what is the answer? 14 times 1.5 pi, which is 21 pi. When you add both, it should add up to 23.25 pi. Do you all get it?
Yes.
Can I move on?
Yes, Priya.
Yes, ma'am.
I couldn't understand how you got the circumference part or the curve area. Yeah.
Okay. That's what Abhyukt here. This is a cylinder, right? Open it in the middle, unravel it. What would happen? This would become a rectangle, meaning this, right? Let me show you in a different color. You'll quickly understand. This circumference, right? When it unravels, it becomes a straight line, correct?
Yes.
The height always remains as the height. Make sense?
Yes.
This is what then? You tell me. In terms of r, how will you write?
In terms of R, we would write as
You unravel it.
2.
You unravel
Oh
the
yeah,
circle.
2R pi.
2 pi r.
Yeah.
So what I'm saying is, I just 2 pi r times the height. That is the area of the rectangle.
Yeah.
2 pi, this one, the height times the circumference times the height. You got it?
Yeah, but what I don't get is that wouldn't there be 2 bases?
Yeah, it'll be 2 bases, but it's a drinking glass.
Okay.
The
I
top
get
is
it.
not there. So it's more of conceptually, if you understand, you'll never make mistakes in these problems. Make sense?
Yeah.
Okay. There will be tricky problems like this. That's why I did not give you the clue. That's what was written there. Remember that the glass has a open top. Okay, now let's go ahead. This is a good one, guys. Guys, I really want you to find, okay? It's a composite solid. It's not a hard one, okay? You just need to apply. That's why I'm saying don't memorize formulas. I really want to know the surface area of this composite solid. You can use calculators. Surface area of this composite solid. Surface area of this composite solid. I don't think you need help. If you need help, let me know. Composite solid means what? It's a 3D solid, but it's made up of simpler figures combined together. Try, guys. Then we'll go to surface area of pyramids. You don't need to memorize any formulas. Done, You're going to answer as a decimal, right? Ashrita, I got. I always suggest you have to have your own calculators. There's no way that you can't. Ashrita, do you have a calculator with you?
Yeah, I was just asking,
No,
would we
no
take
problem.
one?
But do you have a calculator with you?
Yeah.
Okay. Meaning, what is the calculator you have?
TI-84. The graphing calculator.
C plus, right?
I'm not sure. Let me check.
Okay. Johan, not quite Johan. Dhruv, that's correct. Yes, ma?
Priya.
Yes, ma?
So when we're like adding the, cause like normally you would like, I think like how I would do it is like I find the area for the cube and then the half of the cylinder. Do you round and then add, or do you add and then round? Or are we just doing decimals?
Yeah, you find, okay, let me step back a little bit. You will find the area of the cube, surface area of the cube and then the cylinder, but then what you will do for the middle faces don't come, right?
Yeah.
So you'll only find the surface area of 5 faces of the cube and then half of the cylinder. Do you see it?
Oh, yeah.
It's a little, meaning concept, you need to understand things conceptually. You're going to tell me, guys. Let me know if you need help. You have to bluntly say in the chat, you need help.
Priya has the not corrected answer.
Yes. Where did you miss, Johan? Not quite, Johan. Okay, you have something is going haywire, Johan. I don't know what yet. 12 12s are okay. 12 5s are 60. 12 5s are 60. 60 times 12. That should be one answer, right? 60 times 12. 60 times 12 is what? 12 times 6 is 720. 720 should be one answer. How did you get 860? Guys, I think I know what you're all doing.
Yeah, I forgot to subtract the 144, so I did it at the end.
You forgot to subtract the 144. 144, oh, I see. But you should also subtract half of the cylinder as well, right? Did you do that?
Yeah, I did. Might have just made like a silly mistake.
Okay, what happened to the top? The top face of the cylinder, did you add?
Yeah, it was 36 pi, top and bottom.
36 pi, yeah. 630. No, that's incorrect, right? 36 pi is the area. Yeah, top and bottom together is 36.
Bottom is 36, yeah.
Together is 36, correct. But still there's something wrong. Okay, you want me to do that for you?
Yeah, okay.
Okay, let's do. Answer should have been 1059. If you didn't get it, please tell me.
Wait, just Priya, when I put it back into the calculator, I did get 1059.
Okay, that's good. Okay, then we'll move on, guys. Diya, did you get ma?
Yeah, I got the answer.
Can we move on?
Yeah.
Okay. Composite solid, okay, there's one problem, very difficult problem. You go break your head at home. Okay. How about this, guys? Okay. I'm going to replace it. You're able to see my screen, huh? Are you able to see my screen?
Yeah.
Oh, good. Okay, what is this pretty solid?
It's a pyramid.
It is a pyramid. Very good. Okay. What type of a pyramid it is?
Rectangular pyramid.
Okay. So the okay. What is the okay? Let's say, let me put up some values and ask questions so that way I clearly understand who understood. How about this? This is 5. This is 5. This one is a 6. Now I'll put it in different colors. This one is a 4. How much is the green one? How much is the green one? How much is the green?
Would it be the square root of 12?
Why square root of... Oh, okay. Okay. I made a mistake. Yeah, I know, Johan, what you did. That's fine. Good job. Good job. Okay. Let me erase this off. I don't want to confuse. How did you find Johan? You can tell me.
I just did the Pythagorean theorem.
Good. So, whenever it comes to a pyramid, right, what you need to understand is, okay, now if I ask you to find the area of the rectangle, what will you do? Area of the triangle, what will you, meaning, area of the triangle, meaning the four faces are triangles, right? Can you tell me how to find the area of the triangle? So, you found this out. You found this to be square root of 12. He found the green to be square root of 12. So, what is the area of the triangular face? How can we find the area of the triangle? I just want to know which is the height and base. That's all, guys. Go ahead.
Would you just multiply 6 and 4, then divide them by 2?
Good job. This side, the slanted height is there, right? That is perpendicular to the triangular's base. You see, base and height should be perpendicular. So, half times 6 times 4 is the area of the triangle. Make sense? Make sense, guys? Don't take 4. Don't misinterpret and take 4 as the height of the triangle. For the triangle, you have to consider the perpendicular line to the base. What is the height of the pyramid? What is the height of the pyramid?
4.
4. Height of the pyramid is 4. And these things are there, right? These are called lateral edges. These are called lateral edges. Can I move on? Okay, now let's see this one. I want to draw this. Difficult to draw. How about this? Can we try this one? I want you to find out the lateral surface area and the surface area of this regular pyramid. I want you to find the surface area and the lateral surface area of this regular pyramid. Let me write down. You can use calculators, okay? Surface area and the lateral surface area of this regular pyramid. I'm sorry, of this regular pyramid. What type of a pyramid is this? What type of a pyramid is this?
An equilateral triangle.
Nice, yes. Triangular pyramid, great. Can we try this one, guys? See, okay, starting now it's going to be all applications. Whatever we studied. Okay. This is also a regular pyramid, so let's try this one. If you are stuck, please don't memorize formulas, guys, okay? You're all good not memorizing formulas. Go ahead. I can help if you need. But you have to blatantly say, this is my doubt. Let me know if you need help.
said my answer.
Yes. One second, guys. OTP pop. Sorry, guys, I'm here. You want me to explain this? I don't think so, Johan. I'm checking, Johan. No, you are right. But Johan, lateral is correct. The total surface area doesn't seem right. Total surface area, you are going to just add one more triangle, right, Johan? That's a little tricky. Lateral surface area is very easy. Directly it's given. Right? But what is the base area? Base area is a little tricky, I feel. Base area is a 15-15 equilateral triangle. So, what happens if it is an equilateral triangle? Let's see who gets it. Ow! Avyut. Lateral surface area doesn't seem right. Dhruv, for you, I don't know why 10 extra in both. Both have 10 extra. I don't know why.
Oh.
Okay, I'm going to do this. Definitely. Nobody's kidding. Okay. Can I do it at the board, guys? Okay, let's do it together. Okay. There is a base, correct? This is the base. Okay. The base is, it's clearly saying 15, 15, 15. It's an equilateral triangle. Okay, great. Okay. Now, let me find the lateral surface area first. I don't need to be bothered about the base, right? What is the lateral surface area? Let's find out. Lateral surface area. For that, we just need to find, there are 1, 2, 3. 3 faces, right? Lateral. Okay, and then clearly they have given, hey, this is the base. See, they've given 15 as the base, 20 as the height. It's very easy here. So, lateral surface area is very easy. So, one face area is what? Half 25, 15, right? This is one face area. Now, 3 face area is what? Half times 25 times 15 times what? 3. What is the answer, guys?
Priya, isn't it 20, not 25?
Oh, did I make a mistake? I'm sorry. I didn't mean to. Thank you, Johan. Okay, so it will be 10 times 13, 150 times 3, right? 450 centimeter square. Any questions, guys? Can we move on? Okay. Now coming to the total surface area, LSA plus the base area, right? It's tricky. LSA is 450. I don't know the base area. That is the tricky part. Base area, how to find out? This is an equilateral triangle, right? For an equilateral triangle has a special property. If you all remember right? I'm dropping a perpendicular. What happens? What happens to this triangle, guys? I'm dropping a perpendicular. What happens to the triangle? It becomes a
30, 60, 90.
30, 60, 90. So, the hypotenuse of a 30, 60, 90 triangle is 15. Let's first do a 30, 60, 90 triangle. I don't remember. Wait. 30, 60, 90. 1, root 3, 2.
That being the case, the hypotenuse is the 2x, right? The smallest side is the x. The medium side is root 3x, correct? Now, if 2x is 15, x is 7.5, right? So this side becomes 7.5 root 3. This side becomes 7.5. Now what do we need to find the area of this? Half times 15 times, this is my height. Such a messy thing. 7.5 times root 3. Can one of you tell me what it amounts to in a calculator? I really don't know. You want me to sit and please tell me from a calculator. Did you get it? Please do it in the calculator. Let me know, guys. Can be quick. The quicker it is, it's easy. Done.
Uh, 97.4.
Correct, ma. I think that's right. 97.4, huh? Okay, centimeter square. So adding this, what do you get? 450. So the total surface area is what here? 450 plus 97.4, which is equal to 14. What am I doing? 97 na? 97.94. I really don't know what I'm doing. 0.4 and then 7, then 4, 1, 547.4. So it amounts to 547.4 centimeters. Any questions, guys? You have to let me know what questions you have. Do you have any questions? We are good. So there might be 30-60, there might be 30-60-90 often, there might be 40-45-90, all that can come. Now I'm going to give you, see, I'm not bothered about the computations, but I'm really bothered about how you get these. Let's see. I have a square pyramid. It is a regular, it is a regular pyramid, okay? I want you to tell me the lateral surface area. I want you to tell me the lateral surface area of this solid. Okay, now it is a square pyramid. Let's say the height of the square pyramid is 10. The height of the square pyramid is 10. Let me draw it for you. Now the height of this square pyramid is 10. What is the height? This is the height. This square pyramid is 10. However, this is 60 degrees. Can we try? The height of the square pyramid is 10. What is the lateral surface area of this solid? If the diagram is not making sense, you can let me know. Yeah, it's slightly a difficult question. Let me see. If we do this, I'm going to move on to the next subunit. See, geometric mean is an area which I have not covered. I would like to push in side by side with 3D geometry. Let's see. It's a lot to cover, guys, for geometry. Nicely, fully, if you want to cover, it's a lot.
Miss Priya, is it surface area or lateral surface area?
I just want the lateral surface area. You don't need to go to calculation, more calculations.
Okay.
Okay.
I have to plug in my charger, so I'll be right back.
Go ahead. I don't know, guys, you're all obstructed or you're taking time to solve. I don't know. But please be quickly. Tell
I
me
sent
the
my
rest.
answer.
You've sent it, okay. Doesn't matter if you didn't get it, but I'm fine telling yes, ma. That's right. You got it, Johan. Yeah, nice. You want to explain to me, did you send the answer already?
Yeah.
40 seems incorrect. You want to do it on the board of you? I'm okay.
Yeah, sure.
Yeah. Just do it on the board. Let's see where we are missing.
Do you want me to annotate or tell you?
Yeah, annotate. Yeah.
Okay.
We'll find out the mistakes, right? So people won't repeat as well, right? The same thing. Go ahead.
On the bottom, I got 10. I don't know if I can write it. Could you look right for me?
What is it, ma?
I'll feel it hard to write. Could you write it?
Yeah, absolutely. Tell me.
So on the bottom, I got 10 square root 3 over 3.
10 square?
Root 3 over 3.
10 root 3 over 3?
Yeah.
Okay.
And then the
This one, the
and then the
hypotenuse.
hypotenuse was 20 square root 3 over 3.
20 square. Oh, 20 square root. Correct?
Yeah, square root 3.
Okay.
Yes.
Ah.
And then I knew the
LSA is,
and then I found the bottom to whole thing to be 20 square root 3 as well. 20 square root 3 over 3. Yeah.
This is 20 square 3 over 3.
Yeah. And then I multiplied them and divided it by 2.
You multiply them and divide. Okay, let's see. Multiply them like this.
Yes.
And after that?
And then I got
Times 3, right? 4 faces.
4 faces, yeah.
That's it, right?
And then I got 10. I got 20 when I squared them, and then I divide by 2, got 10, and multiplied by 4.
Yeah. So what happens here? 200 times 4 divided by 3 is what I'm getting. Did you get that?
Oh,
it's
I
just
didn't
a
get that.
calculation mistake.
Yeah, probably.
Oh my goodness. Okay. Okay. Answer is what? 266.7. Dia, did you get it?
Yeah, I did.
Okay. Now, did I talk to you about the area of a polygon? Did I talk to you about the area of a polygon?
I think it was like really brief.
Okay. Let's go over that once because you will have a lot of questions on that. Any polygon, guys. It can be a pentagon or it can be a hexagon. This alone I'm asking you to memorize. Half times perimeter times apothem is the area of a polygon. Where P is the perimeter, A is the apothem. Make sense? Okay. Apothem is the perpendicular distance. This is the apothem. Make sense? Any questions? Any questions, guys? You got it? Okay. So now, before I go there, I want to show you this. What is the central angle here? Let's say this is a regular pentagon. What is the central angle here? What is the central angle here? Tell me, guys. This is one basic thing where every geometry kid will make a mistake unless we review this. What is the central angle? Not every, but yeah.
72.
So how did you get it? So this is 360. Did you divide by 5?
Yeah.
So 360 by 5 is a 72 degrees here. So the central angle in a regular pentagon is a 72 degrees. How about this? $60. Do you see something different between them? Meaning there might be, these might form the basis. Okay. So if ever you end up, let's say you want to find the height of this triangle, you have to apply trigonometric ratios. You have to apply trigonometric ratios to find this. Okay. They might give you this angle. You might want trigonometric ratios to find the sides of a pentagon, meaning pentagon, to find the sides of the triangle that are present within the pentagon. Whereas here
In a hexagon, when you look at it closely, you don't need to use trigonometric ratios. You can use 30, 60, 90. See, because this is an equilateral triangle. So basically this will be 30, this will be 90, this will be 60. Because a hexagon, if you know, what is the interior angle of a hexagon? N minus 2 times 180, right? Divide by 6, right? This is 4, right? Do you remember this? This is 120. So when you split it, this becomes 60, 60, 60. This forms an equilateral triangle that does not happen in a pentagon. So this triangle becomes a 30, 60, 90 degree angle. So using that, you can easily find the height of the triangle. Makes sense, guys? What is this height of the triangle? That's the apothem. Do you all get it? So in a hexagon, it's very easy. But in a pentagon, even in class, right, when I was describing 2-3 years back, we noted this as, oh, this is 30, 60, 90 triangle. It won't happen because it's a pentagon. You get it? So it's only, this is 72 degree. When you bisect it, then that will be 36 degrees. Then you have to find using trig ratios. Make sense? Okay, let's move on now. How about this? I want to give you one. This is a good one. You think we'll finish with this? Okay, that's good. Find the surface area of this solid. Let's see. It's going to take a while for you to understand and do. Let's see. Find the surface area of the solid. With that, we'll finish. Let's see. I really want to finish 3D solids quickly. Then only we can move on to. Actually, I did not do geometric mean, which is such an important topic. I'll do that soon after this. Geometric mean similarity. I want to really do that and then move on to probability in circles. Let's push ourselves a little bit. Let's see. Oh, Georgia. Johan, that is not correct. Can you explain?
What I did was I just did 15 times 14 divided by 2 multiplied by 4.
Mama, 1 minute. I have to catch on. Okay, so go
Okay,
slow.
sorry.
15,
I did
15
15
times
multiplied by 14
Uh-huh.
divided by 2
Uh-huh.
multiplied by 4.
Correct. For the top, right?
Yeah, so that was
Perfect.
420.
Okay, I don't have that detail. Okay.
Yeah, I didn't find the bottom one because that would, anyways. And then I did,
Why you did not find the bottom one?
because it would be part of the rectangular prism also, so.
Oh, I see. Okay, but okay. Okay, go ahead.
Yeah, and then I did 14 times 14,
Uh-huh.
and I added that with 12 multiplied by 14 times 4.
Oh my gosh. Okay, okay. So 12 times 14 times 2. Again, 12 times 14 times 2, then 14 times 14. Did you get that?
Why will we only do it by 2?
12 times 14 will be multiplied by 4 faces. And then add 14 times 14. Then your answer is not matching. You are again doing a problem. That's right, Maharshita. Any questions, guys? Just to understand basically what you need to do, then everything becomes so easy.
Yeah, I got a different answer.
Yes, that's correct, Johan. Guys, if you get it, we'll leave here. But then we will work on the next three. Meaning for this week, right? You're going to do till what you know. You're going to do till part 4, 3 and 4. Okay. Please follow with the homework. Don't study separately for the CB and all. Okay. 3 and 4 you're going to do for this week's homework. That's all. 5 I did not work through. I did not give you input, so you can't do. Really, you can't do. So we'll do it next week. 5 and then what do we have? If you get the answers, you can log off if you don't have any questions. If you have questions, stay. You know what? But next week I want to complete this 5, 6. Then how many are there? I think that's it. 5, 6, 7 is a review. Okay. But you know what? 3D solids is another part, volume. Did you get it, guys? You got the answers? If you got it, you don't have a question, you can log off. If you have a question, definitely stay. Yes. Yeah, I can do this one, please. Yeah. If you have that question, immediately ask, I'm saying, right? So here, surface area, how to calculate, guys? What is the base area? Base area is 14 times 14, 196. Right? Then lateral area. Lateral area is what? 14 times 12 times 4. Right? This one. This one. You got it? This one at the back. Okay. Now top is equal to 15 times 14 times half, one triangle times 4. Any questions, guys? Add all these, you get this. Make sense? Any questions?
No.
Okay, guys, I'll stop here now. See you all next week.
Bye, Miss Priya.
Bye, guys.